Hello everyone, my name is Agustin B. I am a third year student of JPTC Kalmasheri. Today I would like to discuss about 7400 series integrated circuits. Introduction. 7400 series is an extended family of digital integrated circuits. Chips in this series include a variety of discrete logic chips such as AND gates, OR gates along with a variety of registers, decoders and RAM units. Some of the 700 series IC are detailed below. Integrated Circuit 7400. IC 7400 is the most widely used TTL device in the world. It contains 4 independent 2-input NAND gates. The logic NAND gate is a reverse or complementary form of the AND gate. The NAND gate has an output that is normally high and only goes low when all its inputs are high. The truth table and the Boolean expressions are shown on the right side of the slide. The figure shows the pin diagram of IC 7400. The pin 1 and the pin 2 are the input of NAND gate 1 and the pin 3 is the output of NAND gate 1. Similarly, pin 4 and pin 5 are the input of NAND gate 2 and the pin 6 is the output of NAND gate 2. Pin 7 is the ground terminal. Pin 8 is the output of NAND gate 3 and pin 9 and 10 is the input of NAND gate 3. Pin 11 is the output of NAND gate 4 and pin 12 and 13 is the input of NAND gate 4. Pin 14 is the VCC pin which is used to provide the power supply to the IC. IC 7402. IC 7402 has 4 2-input NOR gates in 14-pin DIP package. The NOR gate is a digital logic gate that implements logical NOR. NOR is the result of the negation of the OR operator. The special features include large operating voltage range and wide operating conditions. A high output results if both the inputs of the gate are low. If one or both input is high, a low output results. This is shown in the picture right side of the slide with the truth table and the Boolean expression. The figure shows the pin diagram of IC 7402. Pin 1 is the output of NOR gate 1. The pin 2 and pin 3 is the input of NOR gate 1. Similarly, pin 4 is the output of NOR gate 2 and pin 5 and pin 6 is the input of NOR gate 2 and the pin 7 is the ground terminal. The pin 8 and the pin 9 is the input of NOR gate 3 and the pin 10 is the output of NOR gate 3. Similarly, the pin 11 and the 12 is the input of NOR gate 4 and pin 13 is the output of NOR gate 4. The pin 14 is the VCC pin which is used to provide power supply to the IC. Let's move on to the IC 7404. IC 7404 consists of 6 NOT gates in 14-pin DIP package. We note that the NOT gate, also called inverters, because of it does the complements of the inputs. If the input is low, then the output goes high. Similarly, if the input is high, then the output goes low. It is shown in the truth table right side of the slide. This figure shows the pin diagram of IC 7404. The pin 1 is the input of NOT gate 1 and the pin 2 is the output of NOT gate 1. Similarly, the pin 3 is the input of NOT gate 2 and pin 4 is the output of NOT gate 2. And pin 5 is the input of NOT gate 3 and the pin 6 is the output of NOT gate 3. Pin 7 is the ground terminal. Pin 8 is the output of NOT gate 4 and pin 9 is the input of NOT gate 4. Pin 10 is the output of NOT gate 5 and pin 11 is the input of NOT gate 5. Pin 12 is the output of the NOT gate 6 and pin 13 is connected to the input of NOT gate 6. And pin 14 is the VCC pin which is used to provide power supply to the IC. IC 7408. IC 7408 has 4 2-input logic AND gates in 14-pin DIP package. It supports wide operating voltage range and has wide operating conditions. A logic AND gate is a type of digital logic gate that has an output which is normally low and only goes high when all of its inputs are high. The output state of the logic AND gate only returns low again when any of its inputs are low. The truth table and the output expression is shown in the right side of the slide. This figure shows the pin diagram of IC 7408. Pin 1 and the pin 2 is the input of AND gate 1 and pin 3 is the output of AND gate 1. Similarly, pin 4 and pin 5 is the input of AND gate 2 and pin 6 is the output of NAND gate 2. Pin 7 is the ground terminal. Pin 8 is the output of AND gate 3 and pin 9 and pin 10 is the input of AND gate 3. Pin 11 is the output of NAND gate 4 and pin 12 and 13 is the input of AND gate 4. Pin 14 is the VCC pin which is used to provide power supply to the IC. Let's move on to the IC 7432. IC 7432 has 4 2-input logic OR gates in a 14-pin DIP package. IC 7432 are used mostly in digital electronics projects. The OR gate performs logical OR operation, which means the output is high if at least one of its inputs is high. Only if all the inputs are low, the output will be low, and in all other input conditions, the output will be high. The figure shows the pin diagram of IC 7432. The pin 1 and the pin 2 is the input of OR gate 1, and the pin 3 is the output of OR gate 1. Similarly, the pin 4 and the pin 5 is the input of OR gate 2, and the pin 6 is the output of OR gate 2. Pin 7 is the ground terminal. The pin 8 is the output of OR gate 3. The pin 9 and the pin 10 is the input of OR gate 3. Similarly, pin 11 is the output of OR gate 4, and pin 12 and pin 13 is the input of OR gate 4. Pin 14 is the VCC pin which is used to provide power supply to the IC. Now let's discuss the IC 7486. The 7486 IC has 4 2-input logic XOR gates in a 14-pin DIP package. XOR gate is a digital logic with 2 or more inputs or one output that performs exclusive disjunction. Output of the XOR gate is high only when exactly one of its inputs is high. If both inputs of the XOR gate are low, or if the both inputs are high, then the output of XOR gate is low. The symbol and the truth table and the output expression is shown in the figure. The figure shows the pin diagram of IC 7486. The pin 1 and the pin 2 is the input of XOR gate 1, and the pin 3 is the output of XOR gate 1. Similarly, pin 4 and pin 5 is the input of XOR gate 2, and pin 6 is the output of XOR gate 2. Pin 7 is the ground terminal. The pin 8 is the output of XOR gate 3, and pin 9 and pin 10 is the input of XOR gate 3. Similarly, pin 11 is the output of XOR gate 4, and pin 12 and 13 is the input of XOR gate 4. And pin 14 is the VCC pin which is used to provide power supply to the IC. Hope you are satisfied by this presentation. Thank you for your valuable time and have a good day.